Good morning, students. In today's class, we shall discuss some questions from the NCERT Miscellaneous Exercise 2. So, first question, find the value of cos inverse cos 13 pi by 16. So here if we write down that this value is 13 pi by 16, then if you notice this value is in degrees 390 degrees, and hence it does not belong to the principal branch of the cos inverse function. Because the angle is 390 degrees, that means it's an angle in the first quadrant, and in the first quadrant the angle can easily be expressed as 2 pi, that means 360 plus something. So 2 pi plus pi by 6. And because this expresses the first quadrant, so in the first quadrant cos ratio will be positive and we get cos pi by 6, which is equal to pi by 6, and this belongs to the principal branch of cos inverse function. So the value of the function is pi by 6. Next we'll try out here value of tan inverse tan 7 pi by 6. This is equal to 7 pi, if this is equal to 7 pi by 6, that means 210 degrees, then 210 degrees lies in the third quadrant, and you know third quadrant does not belong to any of the principal branches of inverse trigo functions, hence this does not belong to the principal branch of the function. So this angle in the third quadrant can be expressed as pi plus pi by 6. In the third quadrant, the tan ratio is positive, so the result can be written as tan inverse tan pi by 6, which will give us pi by 6, which is an angle lying in the principal branch of the function. So the value of this inverse function is pi by 6. Then let's try third question. So in the third question, we will prove that 2 sine inverse 3 by 5 is tan inverse 24 by 7. So here if we are able to convert sine inverse into tan inverse, then we can easily prove the result. So let us suppose that sine inverse 3 by 5 is theta, which means sine theta is 3 by 5. So if you draw a right triangle here with this angle theta corresponding to the sine ratio, this side should be 3 units, this should be 5 units, and according to Pythagoras theorem, this side is 4 units. So from this triangle we can write down that value of tan theta is 3 by 4, and hence theta will be tan inverse 3 by 4. So here you can see value of theta and this value of theta. Both are same, so can be replaced. So now the left hand side can be written as 2 tan inverse 3 by 4. Now this is to be proved equal to tan inverse 24 by 7. Now we have here a result. 2 tan inverse x is tan inverse 2x upon 1 minus x square, where x is greater than minus 1 and less than 1. So you can see here value of x, which is 3 by 4, and this value 3 by 4 lies in this interval. So we can use the result. According to this result, it has to be tan inverse 2x upon 1 minus x square. And simplifying it further, it is tan inverse 2 into 3 into 4 upon 16 minus 9, which is tan inverse 24 by 7 equal to the right hand side. So the left hand side has been proved equal to right hand side. Next, fourth question, again prove that sine inverse 8 by 17 plus sine inverse 3 by 5 is sine inverse 77 by 85. Now here the book does not give us a formula like sine inverse x plus sine inverse y equal to something. So because this formula is not given in the book, so we'll solve the question in a different way. So we will solve it in two different ways. First method, let sine inverse 8 by 17 be equal to say capital A, and sine inverse 3 by 5 be capital B. So that means sine A is 8 by 17. Here if we draw a triangle, say this is A, so 8 by 17, and using Pythagoras theorem, this side will be 15. Likewise here, this can be written as sine B equal to 3 by 5. Once again, a right triangle, if this is angle B, this side measures 3 units, 5 units, this will be 4 units. Now let us start with the question. We have used here substitution A and B. So let us add A and B. Why adding? Because this is basically A and this is B, so we are adding A plus B. And on the right side we have the sine inverse ratio. So let us take sine of A plus B. Now trigonometry gives us a formula sine A cos B plus cos A sine B. Let's substitute values. We know sine A is 8 by 17. Cos B, this we can find out from here. Cos B is 4 by 5. So multiplied by 4 by 5. Next, cos A. So from here, this triangle we can find out. Cos A is 15 by 17. So 15 by 17 into sine B, which is already given to us, 3 by 5, and this gives us 32 plus 45 upon 85, and left side is sine A plus B. So here we can write it down as A plus B is equal to sine inverse, this value is 77 upon 85. So you can see we have got the right hand side. Now substitute here A is this value, sine inverse 8 by 17, plus B is this substitution, so sine inverse 3 by 5, so that is A plus B, which is equal to sine inverse 77 by 85. So this way we have proved the result. So we have used here basically two substitutions and used here the formula for sine A plus B. This is one method. Now in the second method, we are going to convert these ratios into tan inverse ratios. Now because I have already drawn this triangle here, so we can easily write down what will be A. A can also be written as tan inverse 8 by 15. So the first term can be written as tan inverse 8 by 15. Likewise, for the second term, this is a triangle, so B can be written as tan inverse 3 by 4. So the idea is to convert sine inverse terms into tan inverse terms. Here again you can see that 8 into 50, 8 by 50 multiplied by 3 by 4 is less than 1. So we can use that tan inverse formula, tan inverse x plus tan inverse y formula. According to that formula, we can write down tan inverse 8 by 15 plus 3 by 4 upon 1 minus 8 by 15 into 3 by 4. So we have tan inverse 32 plus 45 upon 60 minus 24. So we have tan inverse 77 upon 36. Now right side is tan inverse, here left side is sine inverse, so we can again make that small change and find out whether the two sides are equal or not, or we can convert this into sine inverse. If this is equal to say theta, then tan theta is 77 by 36, and a right triangle with this angle theta gives us this value 77, 36, and finding out now 77 into 77, 59, and then finding out here 36 square, so that is this, and adding this value and this value gives us how much? This and this value is basically equal to 85 square, so we know this side is 85. So from here we can easily write down that sine theta is 77 by 85, or that theta is sine inverse 77 by 85. So you can see here theta is sine inverse 77 by 85, theta is also tan inverse this, and hence tan inverse 77 by 36 can be replaced by sine inverse 77 by 85, which gives us the right hand side. So two different methods of solving the same question. Question number 8. Prove that tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8 is pi by 4. There are 4 tan inverse terms. You can multiply them in any order, going by the order given in the question only. So here for this first case, we will just check that this product is less than 1. So for the first sum of first 2 terms, we can use this identity, tan inverse 1 by 5 plus 1 by 7 upon 1 minus 5 into 1 by 7. Simplifying this further, we have 7 plus 5 upon 35 minus 1, that is tan inverse 12 by 34. Likewise here in the next term, the product of 1 by 3 and 1 by 8 is less than 1. So here again we can use the same identity, 1 by 3 plus 1 by 8, 1 minus 1 by 3 into 1 by 8. Simplifying further, 8 plus 3, this is 24 minus 1, so that is tan inverse 11 by 23. So here we are getting tan inverse 6 by 17 plus tan inverse 11 by 23. Again product of sum of 2 tan inverse terms. Let us again check 6 by 17 into 11 by 23. Both numerators are less than denominator, so the product would be less than 1. Now since the product is less than 1, so we can once again use the identity tan inverse 6 by 17 plus 11 by 23 upon this. Now performing this simplification, so 17 into 23, 391. So what do we get here? So we get here tan inverse 1, which is equal to pi by 4, and that is equal to right hand side. So this way the result has been proved. So next question number 10. Here also we are proving that cot inverse under root 1 plus sin x plus under root 1 minus sin x upon under root 1 plus sin x minus under root 1 minus sin x. This is equal to x by 2, where x belongs to the open interval 0 to pi by 2. So here one of the methods is to rationalize this expression. So let us rationalize. This expression is to be rationalized, so we multiply it by under root 1 plus sin x plus under root 1 minus sin x upon the same expression. So here numerator, you see, it is just like a plus b into a plus b, so that is a plus b whole square. So that should give us a square, which is this, plus b square, which is this, plus twice of a into b. So that I'll write down like this. And in the denominator, it is like a minus b into a plus b, which is a square minus b square. So this is a square minus b square. So moving on to next step. Here you can see this and this gets cancelled. So 1 plus 1, 2 plus twice. This is under root 1 minus sin square x. Denominator 1 plus sin x minus 1 plus sin x. So here plus 1 minus 1 gets cancelled, and we have here cot inverse, taking 2 common in numerator, 1 plus this value is cos square, and square root gives us cos x, and in the denominator we have 2 sin x, so here 2 also gets cancelled. So using identities, here we have 1 plus cos x. 1 plus cos x is 2 cos square x by 2. The denominator is sin x, which can be written as 2 sin x by 2 cos x by 2. So 2 gets cancelled, 1 cos term gets cancelled. So we have cot inverse cot x by 2. Now this result will be x by 2 if this value lies in the principal branch. So let us again check here. We are given here that x is greater than 0, less than pi by 2. Our angle is x by 2. So dividing by 2, we get this. And the principal branch of the cot inverse function is basically this. This is the principal branch, and this is a subset of the principal branch. Hence, the result can be written as x by 2, which is equal to the right hand side. So next we are doing 11th question. Tan inverse under root 1 plus x minus under root 1 minus x on under root 1 plus x plus under root 1 minus x. This is equal to pi by 4 minus half cos inverse x, where x is greater than equal to 1 by root 2, less than equal to 1. So here is a variable. So for this variable, let us substitute x is equal to cos 2 theta. You can also take cos theta. So this makes it cos inverse x is 2 theta, or theta can still be written as half cos inverse x. So left hand side, let's substitute 1 plus cos 2 theta under root 1 minus cos 2 theta. And this is the denominator. And using the identities here, this is 2 cos square theta minus under root 2 sine square theta, and likewise we get this in the denominator. So here you can take root 2 common from numerator and denominator. Simplifying it further, we get cos theta minus sine theta upon cos theta plus sine theta. So here, if we divide the numerator and denominator by cos theta, we get tan inverse 1 minus tan theta upon 1 plus tan theta, which can also be written as tan inverse tan pi by 4 minus theta. The result will be equal to pi by 4 minus theta only if pi by 4 minus theta belongs to the principal branch or subset of the tan inverse principal branch. So for this we are given this information: x is greater than equal to 1 by root 2, less than equal to 1, and we know x is cos 2 theta. So cos 2 theta. Here, since cos is a decreasing function, so these inequality signs change, and we can write down like this. So finding out the principal branches, this is pi by 4 and this is 0. The angle we need is theta, so dividing by 2. Again we need the angle to be minus theta. Once again these signs will change. So multiplying by minus 1 this way, adding pi by 4. So when we add here pi by 4, we get pi by 8. So this way we get to know that this angle lies in the subset of the principal branch of the tan inverse function. Hence this result can be written as pi by 4 minus theta, and substituting theta, which is written here, we get minus half cos inverse x, which is equal to the right hand side, and hence the result is proved. Question 13. An equation is given: 2 tan inverse cos x, which is equal to tan inverse 2 cosec x, and here we are solving the equation. That means we are finding out values of x that satisfy this condition. So here you can see the left side is something like 2 tan inverse x. So we can use this formula: 2 tan inverse x is tan inverse 2x upon 1 minus x square. So let us use that formula here. So we will get here tan inverse 2x, we are replacing by cos x, upon 1 minus cos square x. On the right side, tan inverse 2 upon sin x. The equation is something like tan inverse x equal to tan inverse y, so we can write down that x is equal to y. So we are not kind of cancelling this, alright. Our equation is of this kind: tan inverse x equal to tan inverse y, hence x is equal to y. So we have 2 cos x upon sine square x, which is equal to 2 sin x. So this constant can be cancelled, and here since sin x cannot be 0, one of the sine terms can also be cancelled, and we get this, which can be written as tan x equal to 1 or even cot x equal to 1, which is also tan x equal to tan pi by 4. And this is a standard trigonometric equation. For this equation, the standard result is n pi plus pi by 4, where n is an integer. So these are the values of x that we have found out. These values of x will satisfy this condition. Now the question here is, why did we take this to be not equal to 0? Imagine sin x is 0. If sin x is 0, it becomes 2 upon 0, something which is not defined, and the tan function is not defined whenever the angle is pi by 2, and pi by 2 is not included in the principal branch of tan inverse function. Hence we have excluded this term here. So this is the general solution of this equation. Then a similar kind of question, that is question number 14. Tan inverse 1 minus x upon 1 plus x equal to half tan inverse x, where x is greater than 0. So here this factor of half is shifted to the left hand side, and we have 2 tan inverse 1 minus x upon 1 plus x equal to tan inverse x. Now using the same identity here, 2 tan inverse x can be written like this. So it is tan inverse 2 into this term upon 1 minus square of this term, and on the right side tan inverse x. Again using this result here, we get x is equal to y, so this expression is equal to this. So I am trying to simplifying it also simultaneously. So 2 1 minus x into 1 plus x upon 1 plus x whole square minus this whole square is equal to x. So x is equal to y. That's what we have written here. Still simplifying it further, 2 into 1 minus x square, and here 1 plus x square plus 2x minus 1 minus x square plus 2x equal to x. So some terms cancel off, and next what do we have? 2 into 1 minus x square, denominator is 4x, which is equal to x. So this gets cancelled, and we have 1 minus x square is 2x square, or 1 is equal to 3x square, and therefore x is equal to plus minus 1 by root 3. We are getting two values of x, but the question says x has to be greater than 0. Therefore the only possible value of x is 1 by root 3. Now supposing these kinds of questions come in exam and we leave the answer in this form, that means we shall be suffering a loss of half mark, because this given condition was not used to find out of the two solutions which one is possible. So now we are moving to a very important question. This question has been asked in the board exam for 4 marks, and some equation is given: sine inverse 1 minus x minus twice sine inverse x is pi by 2, and we have to find out here value of x. So we will shift this term to the right hand side. Sine inverse 1 by x is pi by 2 plus 2 sine inverse x. The same equation can be written as 1 minus x sine pi by 2 plus 2 sine inverse x. Now here we can use an identity, trigonometric identity, sine pi by 2 plus theta. This is in the second quadrant, so sine ratio will remain positive, and sine pi by 2 plus theta will become cos theta. This is theta. So cos 2 sine inverse x. So let us here suppose that sine inverse x is theta, and hence x is sine theta. This is what we are finding out. So using this substitution here, our equation is 1 minus x cos, here we can write down 2 theta. This x can also be replaced. What is x? Sine theta. Right, this is the equation. And here once again we know there is a formula for cos 2 theta which defines it as 1 minus 2 sine square theta. So here this constant gets cancelled, the negative sign also gets cancelled. Sine theta we are not cancelling, so we can write down the equation as sine theta minus 2 sine square theta equal to 0. Why have we not cancelled sine theta? Because sine theta is basically x, and that's what we are finding out. So we cannot delete one of the x's here. So we are getting sine theta 1 minus 2 sine theta equal to 0. This gives us sine theta is 0, or the other value is sine theta is 1 by 2. Sine theta means x. So we have got here two values of x. X is 0 and x is half. Now whenever we get more than one solutions, we have to explore whether both the solutions are possible or should we reject one. So this checking is necessary. So let's start with x is equal to 0. Substitute it here. So we are checking here x is equal to 0. What is the left hand side? So if x is 0, the first term is sine inverse 1. This is 0, so this term is minus sine inverse 0. Simplify, sine inverse 1 is pi by 2. This is 0, so left side simplifies to pi by 2, which is same as the right hand side. So left side, right side are same, that means x equal to 0 is possible. Next, we'll try for the other value of x. So for x is equal to half, again check. If x is half here, the first term is sine inverse 1 minus half, which is this, minus 2 sine inverse half, which becomes minus sine inverse half, and if you simplify, you get minus pi by 6, which is not equal to the right hand side. So that means we can reject x equal to half. So what is only possible here is x is equal to 0. So this is again an important step. You get two solutions. You have to check out of the two solutions, if one needs to be rejected, reject and accept one of the solutions.